Dear students, very good morning. I am Dr. T. Paradesi, Associate Professor from Department of Chemistry. In this video lecture, I am going to talk about the classical mechanics and quantum mechanics for engineering graduates, engineering students. The topics to be covered in this lecture are classical mechanics, that is a black body radiation, and Wein's law, Rayleigh-Jeans law, followed by Planck's hypothesis and de Broglie hypothesis, Heisenberg uncertainty principle, and finally Schrodinger time-independent wave equation derivation. So the classical mechanics explain about the motion of macroscopic particles. Every day we are looking at various objects. Okay, so the movement and velocity and speed, whatever it is related to that, we can easily understand with the help of classical mechanics. So it explains only the motion and interaction of macroscopic particles. So it is purely based on Newton's law of motion and the concept of force. This classical mechanics explain the phenomena such as motion, momentum, energy, and gravitation. It works well for the object which is moving at high speed, much lower than the light, velocity of light, speed of light. However, it fails to explain about the microscopic particles. So the momentum and motion of microscopic particles, this theory does not work well. So for this, various scientists to explain the drawback of classical mechanics, they have framed various ideas such as this. Look at this picture. These are all the scientists, those who involved in development quantum mechanics in various aspects. De Broglie, Einstein, and Schrodinger, Max Planck, and quantum. These are all the scientists involved in the development, and they explained about the drawbacks of classical mechanics, and based on the concept of classical mechanics, they have redefined and explained the quantum mechanics. So just overlook about the drawbacks of classical mechanics. It deals mainly with macroscopic objects based on Newton's law, and the position and momentum can be determined accurately, and the particle behavior is usually predictable. These are all the concept of these are all the concept of classical mechanics. Okay, so the simple example to understand the classical mechanics: movement of a car. If the car is if you look at the car in the roadside, so you can see the objects, that is car, and you can easily measure the speed of the car since it is a macroscopic object. Suppose in case if you are looking at the particle, you cannot able to see the particle. First of all, electron, proton, neutrons, tiny particles. Okay, microscopic particles, even micro, we cannot able to see in our naked eye. So in that case, the classical mechanics concept is not enough to deal with the motion and speed, whatever the phenomenon, can't able to understand. Okay, so that's why various theorems and hypotheses are used to explain the quantum mechanics. Okay, now the main drawback of this classical mechanics is black body radiation. Okay, classical physics predicted an infinite amount of energy at shorter wavelength known as the ultraviolet catastrophe. This was resolved by Planck's quantum theory. And it fails to explain about the photoelectric effect, atomic stability, and atomic spectral lines. Now, what is meant by this black body radiation? The energy which is emitted from the black body, that is called black body radiation. Look at the picture in the next slide. See, just imagine it is a black body. Okay, Now you are allowing a radiation to fall on it with this slit. So the radiation passes through this pinhole. Okay, it hit on the wall. It hit on the wall here. Again, it is emitted. It is emitted here, and again it is emitted here. Again, it is emitted here. So the energy is absorbed and emitted. The energy is absorbed and emitted. Okay, right. So this is a continuous cycle. To the maximum, it is absorbed, and finally, it is released. Okay. So this a perfect black body is the one which absorbs and emits all the radiations. So this radiation is known as black body radiation. Okay. Now look at the spectrum. With this spectrum, there are two different concepts that arise. One is Wien's displacement law and Rayleigh-Jeans law. Look at the previous slide. Okay, I am able to move it. Okay, I will show in the next slide again. So two concepts are given in the classical mechanics, like Wien's displacement law and Rayleigh-Jeans law. So Wien's law explains about the product of maximum wavelength and temperature is a constant. Okay, so the product of the maximum absorbance, that is called a lambda max, and the temperature is a constant. Okay, Rayleigh-Jeans law explain about the energy of the particle is inversely proportional to the wavelength and directly proportional to the temperature. Look at E. Look at this E energy. Energy is inversely proportional to the fourth power of lambda and directly proportional to temperature. So these two laws are successfully explained by the scientists. However, the Wien's law is applicable only for shorter wavelength. On the other hand, this Rayleigh-Jeans law is applicable only for longer wavelength. So this is the pinhole to make a conclusion that for any kind of absorbance spectrum or anything, two different concept, that is for this is applicable for shorter wavelength, this is applicable for longer wavelength. That kind of concept is not at all acceptable, not at all give a proper solution. So Planck's Planck's derive some equations based on these two concepts, and he deduced the energy equation. That equation is the key point for the development of quantum mechanics. Because for one kind of radiation spectrum, for shorter wavelength certain rule and longer wavelength certain rule is not appropriate. So that he developed a new energy equation. Okay, so look at the same thing in the previous slide. What I explained about the spectrum, energy spectrum. Here, if you are going for higher temperature, look at 4000 Kelvin, 6000 Kelvin, 7000 Kelvin. If you are moving to higher temperature, it shifted to shorter wavelength. If you are moving higher temperature, it is shifted to shorter wavelength. The energy so shorter wavelength means energy will be high. So increasing temperature leads to higher energy. Okay, this is applicable for shorter wavelength. Okay, right. So these are all various energy spectrum. So the shape of the curve is uniform look at in the black body radiation curve energy spectrum. The shape of the curve is same for all the temperatures, and the wavelength corresponding to the maximum, that is lambda max, shift towards lower wavelength. That means it gives higher energy. For all wavelength, an increase in temperatures causes an increase in energy. Okay, so these are all the concepts for black body radiation. Okay, so due to this conflict of shorter wavelength and longer wavelength, uh, Planck introduced the new energy equation based on the concept that Planck suggests that energy in the radiation is related to the frequency. So he deduced the equation E is equal to NH nu. Nu is the frequency. So n is the positive integer called quantum number. What he proposed that the energy is not in continuous, it is released in packet of energy, a discrete packet of energy. So he used the word to describe the energy as a photon. So the energy level, and what another thing, the energy level from 0 to 1 or 1 to 2 or 2 to 3 or 3 to 4, whatever it is, it should be in the H nu difference. Okay, so the energy gap should be, yeah, H nu, 1 H nu, 2 H nu, 3 H nu, 4 H nu. It is going like that. So, what the Planck's radiation assumption? A black body contains electrons which are capable of vibrating with all possible frequencies. The frequency of radiation emitted by an oscillator is same as that of frequency of its vibration. The oscillator radiates energy in discrete manner, not in continuous. So he derived the equation E is equal to NH nu. So this is the theory of quantum theory of radiation from Planck's concepts. So what he concluded, a body can emit or absorb energy only in whole number multiples of 1 H nu, 2 H nu, 3 H nu, like that. Okay. Now, so these are all the things I explained. I have already explained about the Planck's hypothesis. Energy is not emitted continuously. It is absorbed or emitted in small pockets of energy, that is called quanta. Energy of one quantum is equal to H nu. This concept is well aligned with black body radiation. So the energy equation derived by Planck is based on the Wien's and Rayleigh-Jeans law. So he deduced the energy equations. We no need to go for derivation part. Okay. So finally, what he conclude? Yeah, this is the final equation of Planck. E is equal to 8 pi hc by lambda power 5 into 1 by e power minus h nu by kt minus 1 d lambda. This equation is known as Planck's radiation law in terms of wavelength. So this equation is well aligned with shorter wavelength and longer wavelength. For both the shorter wavelength and longer wavelength, this equation is acceptable in terms of energy calculation. Yeah, this is the explanation for deduction of Wien's displacement law and deduction of Rayleigh-Jeans law from Planck's concepts. So according to his, this equation is reduced to energy in both the terms. Okay, right. Now let us move to the next concepts. De Broglie, that is, so according to Einstein, light has a dual character, that is wave and particle nature. So de Broglie thinks that light is in the universe, matter is also in the universe. Since light has dual character, why not matter? He is thinking like that, and he deduced the equations based on the Einstein concept and the Planck's concepts. He deduced the wave that is called the de Broglie wave. For this invention, he was awarded a Nobel Prize in the year 1929. So the hypothesis of de Broglie is, since the nature loves symmetry, light has dual character. Same what I have explained. Why not matter? So matter also exhibits the dual characters. Okay, so that wave associated with the material particle are known as matter wave or de Broglie wave. Very simple equation derived by easily you can understand the concept of de Broglie. Okay, look at the derivation. Just look at E. According to Planck's theory, E is equal to h mu. According to Einstein, concept, E is equal to mc square. Just equate these two. So h nu is equal to mc square. We know mu is equal to c by lambda. So h c by lambda. So c cancel here. So lambda is equal to h by mc. Here c is the velocity of light. But according to de Broglie, uh, he is deriving for particle. So particle velocity, he used the word v for the velocity of a particle. So lambda by h by mv. Lambda equal to h by mv. H is Planck's constant, m is mass of the particle, and v is the velocity of the particle. So the wave associated with this particle is known as de Broglie wave. Yeah. Okay. The next topic, Heisenberg uncertainty principle. Already you have studied in the school level. So we cannot determine the exact position and momentum simultaneously with utmost precision. So any one can be determined with precision, but we cannot determine both the position and momentum of a particle simultaneously. So this can be explained mathematically by the change in position and momentum del x del p is greater than or equal to h cross by 2. Okay, now let us move to the next topic, that is Schrodinger wave equation. Okay, so this is one of the important topic in the quantum mechanics. Okay. So Schrodinger derived wave equation which explain about the identification of a particle. Say, look at a particle. If you want to locate the particle, so this is going like that. Okay, right now I will change here. Look at, this is the particle. Look at, this is a particle. Okay, the green color is a particle which is associated. Look at the particle has dual character. Okay, so wave nature is also there. Now the wave which is associated with this particle, with this moving particle, is determined by this Schrodinger time independent wave equation. Okay, so now let us consider this wave which is associated with the particle which is located here as a green color mark. Okay, right now this now let us consider the x, y, z axis. Okay, so x, y, z. So three different axes are there. So let x, y, z be the coordinates of the particle, and xi is the wave function. Xi is the wave function. Wait, I green color. Okay. Change the color. I will change in red color. Okay, psi be the wave function of a de Broglie wave at any given instant of time t. Okay, so uh, the derivation is started with the classical equation. So the classical differential equation for this wave motion of the particle is given by this equation. This is the classical equation. Dou squared psi by dou x square plus dou squared psi by dou y square plus dou squared psi by dou z square equal to 1 by v squared into dou squared psi by dou z square. Sorry, dou squared psi by dou t square. This is equation 1. This is the classical equation. So here v is the wave velocity. Now this equation can be written as del squared psi equal to 1 by v squared dou squared psi by dou t square. What is del squared? Del squared is nothing but dou squared psi by dou x squared, dou squared psi by dou y squared, dou squared psi by dou z squared, sum of. So this is called Laplacian operator. This is the mathematical term, Laplacian operator. So the solution for this equation 2 in terms of time t is given by xi equal to xi naught e power minus I omega t. Whereas xi is the function of x, y, z and t, xi naught is the function of x, y, z. So the solution for equation 2 is xi equal to xi naught e power minus I omega t. Right. Now let us differentiate this equation 3 with respect to t. So you should know a little bit mathematical terms to understand and derive the equation. Okay, so equation 3 should be differentiated with respect to t. Dou psi by dou t. Here we are all using dou because the particle is moving along 3 different axes. So that we are using partial differentiation. So dou psi by dou t is equal to xi naught e power minus I omega t into minus I omega. Okay, again if you are differentiating, dou squared psi by dou t squared equal to xi naught e power minus I omega t into minus I omega into minus I omega. So minus I omega into minus I omega, we can find out I squared omega squared. I squared omega squared. In mathematical terms, we know that I squared equal to minus 1. So that the term will be replaced by minus omega squared, and this whole term is nothing but psi. Based on equation 3, psi equal to psi naught e power minus I omega t. So this term will be replaced by psi. So finally what we are getting? Dou squared psi by dou t squared equal to minus omega squared psi. Apply this value in equation number 2. So we know that equation number 2, del squared psi equal to dou squared psi 1 by v squared into dou squared psi by dou t squared. So 1 by v square into dou squared psi by dou t squared is nothing but minus omega squared psi written here. That is minus omega squared by v squared into psi. Just rearranging, del squared psi plus omega squared by v squared into psi equal to 0. Equation 5. Right. Now, we know that omega is the angular frequency. Omega is nothing but angular frequency. So the formula of omega is equal to 2 pi nu. Nu is the linear frequency. Omega is the angular frequency, nu is the linear frequency. So omega equal to 2 pi nu. We know that nu equal to c by lambda, but here particle, so v by lambda. So 2 pi v by lambda. 2 pi v by lambda. Just rearranging, we will get w by omega equal to 2 pi by lambda. From this, we can identify easily just omega squared by v squared. So what we will get it omega squared by v squared? 4 pi squared by lambda squared. Just apply in equation 5. So this value to be applied here. This value should be applied here. So del squared psi plus 4 pi squared by lambda squared psi equal to 0. Okay, look at the next. Yeah, del squared 4 pi squared plus del squared psi plus 4 pi squared by lambda squared into psi equal to 0. Okay, right. Now we know that lambda is equal to h by mb. Then lambda squared is equal to h squared by m squared v squared. That's all. Apply here. Del squared psi plus 4 pi squared by, instead of lambda squared, apply h squared by m squared v squared. So this term will go here. So del squared psi plus 4 pi squared m squared v squared by h squared psi equal to 0. Equation 9. Now the energy of the particle, that is the total energy of the particle, is the sum of the potential energy and kinetic energy. So that energy is equal to total energy is equal to potential energy and kinetic energy. So E is equal to V plus of mv squared. That is, this is total energy, this is potential energy, this is kinetic energy. So from this, just rearranging, 2 into E minus V is equal to mv squared. Multiplying m on both sides. Why? Because we need to get the value of m squared v squared here. So that you are multiplying m both sides on with m. So 2m into E minus V is equal to m squared v squared. Apply this m squared v squared in equation 9. What we will get it? Just look at del squared psi. I will highlight. Yeah, this one. Yeah, I will highlight here. Del squared psi plus 4 pi squared by h squared. Instead of mv squared, you can write 2m e minus v into psi equal to 0. Let us see in the next slide. Yeah. So once you applied del squared psi plus 4 pi squared m, 4 pi squared 2m, that means 8 pi squared m into E minus V by h squared psi equal to 0. Okay, right. Now actually this is not exactly, further we need some derivation. Here we are using h squared. Actually Schrodinger derived the equation based on the reduced Planck's constant, that is h cross. We know that this is h cross is the reduced Planck's constant. H cross is nothing but h by 2 pi. Reduced Planck's constant is represented by h cross is equal to h by 2 pi. Yes, I have written here. Yeah, this is h cross equal to h by 2 pi. So we can simply find out h cross squared equal to h squared by 4 pi squared. Okay, here a lot of confusion. You just from this you can just find out what is h squared. H squared is nothing but h squared equal to 4 pi squared h cross squared. That's all. 4 pi squared into h cross squared. That's all. Apply this value. H squared is equal to 4 pi squared into h cross squared. Apply this value here. Apply this value here. Apply this value here. So you will get the final equation, that is del squared psi plus 2m by h cross squared into E minus V into psi equal to 0. Del squared psi plus 2m by h cross squared into E minus V into psi equal to 0. This is the final equation, time independent Schrodinger wave equation. Okay, right. So from this equation we can find out, we can locate the particle where it is. Okay, the particle is moving in any direction, so we can locate the probability of finding. So the ultimate objective of the study is to identify the particle. Probability of finding exactly probability of finding the particle. So the wave function psi has no direct physical meaning. It is a complex variable quantity. It gives complex information about the physical system, that is its position at any instant of time t seconds. So the wave function relates the particle and wave nature of matter statistically. It is a complex quantity. It is a complex quantity, and hence we cannot measure it accurately. We can find only the probability. So the probability is if the integral of psi squared, that is the integral of psi squared is 1 if the particle is present. If the particle is absent, then this is 0. If it is 0, if psi squared is 0, the particle is absent. Psi squared dx dz is 1, then the particle is present. Okay, so this is the one of the important equation in quantum mechanics. Based on that, we can find out the energy of the particle. So in the next video lecture, I will explain about the applications of Schrodinger wave equation. So this is the equation which is used to find out the probability whether the particle is there or not. Probability of finding the particle. Okay, so based on this equation, we can go for the next lecture hour. In the next video, I will explain about the energy of the, how can we derive the energy of the particle, what is the probability of finding the particle in the box, in one-dimensional box, particle in one-dimensional box. Suppose the particle is moving only in x-axis or in y-axis. Okay, so the particle is moving in one direction, one axis. So what is the probability of finding? What is the energy of the particle? That can be explained by Schrodinger wave equation. So I will explain those concepts in my next video lecture. Thank you, students.